Okay, Assalamualaikum warahmatullahi wabarakatuh. So let's continue on 4.11, hypothesis test to compare more than two population mean, also known as analysis of variance or ANOVA. Okay, so previously you already learned on hypothesis testing to comparing, okay, either for one population mean or the difference between two population means, and also in terms of single variant, and also the difference or ratio between two variants, and single proportion, and the difference between two proportion. Okay, so now we will look into what are the suitable hypothesis testing if we have more than two population mean, meaning that if we have a population starting from 3, 4 and above. Okay, so the analysis of variance, also known as ANOVA, is a procedure used to test the null hypothesis that the mean of three or more independent population are equal or not. Okay, so the purpose is we want to test whether the population mean are equal or not. Okay, for example, suppose that an educationist is interested in how the average mark in a standard test varies among three groups of students treated with different teaching methods. Okay, sample of 4 students from each group are selected. Okay, so meaning that in this example, okay, we want to study whether the average mark, okay, of a student, which is we have 3 group of student where each group has been teaching with different teaching method. Okay, so for example, meaning that here we have group A, group B and group C. Okay, so meaning that group A has been taught a different teaching method, same goes to group B and group C. So apa yang kita nak tengok kat sini adalah whether the average mark, okay, the average mark, is there any difference between teaching method A, B and C. Okay, so in this experiment, okay, for teaching method A we have 4 student. Okay, for teaching method B we have 4 student, and teaching method C we have 4 student. Okay, so this one is 4 student also. The total experiment, the total sample size that we have here is 12. Okay, so based on this statement or based on this example, what can we identify here? Okay, so this we call it as an experiment. Okay, in identifying whether the average mark of a group of students are different or not. Okay, so there are several definition that you should understand here. First is, what is treatment? Okay, so a treatment is something that researchers administer to experimental unit. Okay, so meaning that here the treatment here adalah our teaching method. Okay, so we want to we are interested to see the effect of the teaching method. So the teaching method has been applied on the 3 group of student, okay, where the 3 group of student are known as the experimental unit. Okay, so meaning that what are you interested to study? So we on what things or people that we apply what we are interested to study. Okay, so the thing or the people that we employ the study, we call it as experimental unit. Okay, next terms we have factor. Factor is a general type or category of treatment. Okay, so since tadi treatment kita adalah teaching method, and then we have 3 different teaching method, A, B and C. So the teaching method ada treatment which have 3 level of a factor. Okay, we have method A, method B and method C. So in summary, the student are the experimental unit, the teaching method are the treatments, and the three type of teaching method constitute the three level of the factors. Okay, so you have to understand, and also you should also can differentiate what are the difference between experimental unit, treatment, and also the factors. Okay, sometimes the question will asking you or ask you to identify what are the treatment, what are the experimental unit, and also what are the level of the factors. Okay, so in summary, the one-way analysis of variance allow us to compare several groups of observation, all of which are independent but possibly with a different mean for each group. A test of great importance is whether all the means are equal. Okay, so based on this example, since we have three different groups, which is referring to the three different teaching methods, so we want to know whether the mean of the average, so the average mark. Okay, apa yang kita collect kat sini adalah in term of average mark of the student. Nak tengok ada beza tak score terhadap the three different teaching method tu. So kita nak tahu adakah mean average score by using teaching method A is equal mean or average mark of the teaching method B, and also average mark of teaching method C. So the suitable test that we can use is called one-way analysis of variance or ANOVA. Okay, before we go further, let's take a look into completely randomized design or CRD. Okay, this design is referring to the analysis of variance that we want to conduct. Okay, this is the others name for or one of the type of the under analysis of variance or ANOVA. Okay, so there are several types or several experimental design under analysis of variance, but we only focus on CRD. Okay, in a completely randomized design, object or subject are assigned to groups completely at random. Okay, one standard method for assigning subject to treatment group is to label each subject, then use table of random numbers to select from the label subject. Okay, for example, based on the same example on the different teaching method that I have mentioned previously, so we have teaching method A, method B, and method C, right? Okay, so we want to assign method A to 4 different students. Also, same goes to teaching method B. Student 1, student 2, student 3, and student 4. And for teaching method C, we have student 1, student 2, student 3, and student 4. Okay, so how to choose all these students? Okay, the process in assigning the student to the 3 different teaching method is conducting by random. Okay, so for example, in a class we have 12 students. Okay, so we want to assign 4 students to teaching method A, 4 students to teaching method B, and 4 students to teaching method C. Okay, so what should you do? So we should do in, let's say, in a box. Okay, we put 12 strip of paper. Okay, 12 strip of paper. Okay, and then for each label A, B, and C. Okay, kita labelkan lah, katakan okay, ni A, this one B, and last one kita ada C, and C. Okay, so next we randomly call a student. Okay, so we select a letter from each box. Okay, so for example, the first letter was C. Okay, so then the first student would be taught method, teaching method C katakan. Okay, and then we repeat without replacement until all students have been assigned a method. Okay, katakan the next chosen one is A. So maksudnya student yang kedua we will assign teaching method A. Okay, until all the 12 paper has been selected. Okay, the next thing that you have understand and also remember also, what are the assumption of one-way ANOVA. So there are 3 specific assumption that should be fulfilled prior to conducting one-way ANOVA. So the first one, the population from which the samples are drawn are approximately normally distributed. Okay, number 2, the population from which the sample are drawn have the same variance or same standard deviation. Okay, the last one, the sample drawn from the different population are random and independent. Okay, so you should remember and understand, okay, the assumption in conducting one-way ANOVA or analysis of variance. Okay, first, population are normally distributed, population have same variance, and samples are random and independent. Okay, now let's take a look into the ANOVA table calculation. Okay, in conducting hypothesis testing for completely randomized design, it is advisable to summarize the calculation in the ANOVA table as below. Okay, so the ANOVA table consists of 5 columns. Okay, first column we have sources. Okay, the sources is divided into treatment, error, and total. Okay, and then we have second column, we call it as sum of squares. Okay, so we have sum of square for the treatment, sum of square for the error, and sum of square for the total, denoted by SSTO. And then we have column number 3, we call it as degree of freedoms. Okay, DF. Okay, so the formula for degree of freedom for the treatment is K minus 1. So what is K? K is the number of treatment that involved in the experiment. Okay, and then for the degree of freedom for error, the formula is capital N minus K. So the capital N is the number of observation or sample that involved in the experiment. Okay, so capital N minus K, meaning that the number of sample that involved in the experiment minus the number of treatment. Okay, and then the degree of freedom for the total is capital N minus 1. Okay, the number of sample involved minus 1. Okay, and then we have column number 4, which is mean squares. Okay, first one is mean square for the treatment, denoted by MSTR. Okay, so MSTR is equivalent to SSTR divided by K minus 1, or some column. Okay, in simple word, okay, for mean square, cara dia adalah column sum of square divided by degree of freedom. That's why to find the mean square for the treatment, we take sum of square treatment divided by degree of freedom, SSTR divided by K minus 1. And then for MSE, we take the value of sum square error divided by degree of freedom. Okay, meaning that SSE divided by N minus K. Column number 2 divided by column number 3. Okay, and then the mean square for the total, memang tak ada. So this one memang tak ada. Okay, and then lastly, you have to calculate the value of F. F here is referring to the F value lah. Okay, so F value is equivalent to MSTR divided by MSE. We take the value here and divide by the value of MSE. Okay, so dia memang ada satu sahajalah kat sini untuk kolom F ni. Okay, so this is how the ANOVA table looks like. Okay, remember it has column sources, sum of square, degree of freedoms, mean square, and f. Okay. Okay, as for example, I'm using the same example that I have explained previously on the 3 different teaching method. Okay, so let's say we have teaching method A, method B, and method C, right? Okay, and then we have this one we administer into 4 different student. This one also 4 different student, and for teaching method C also 4 different student. Okay, so meaning that here we have our treatment, which is K, is equivalent to 3. Okay, teaching method A, method B, and method C. Okay, now our capital N here is equivalent to 12. Okay. So in order for you to complete the degree of freedom for the ANOVA table, for example, so for this example, this one for degree of freedom for the treatment, we have 3 minus 1. So meaning that the value degree of freedom here is 2. And then the degree of freedom for error here, we have 12 minus 3, we have 9. Okay. So kat sini tadi contoh dia 3 tolak 1, 2. This one 12 minus 3 is 9. This one capital N minus 1 is 11. Ataupun kalau nak check, when you total up 2 plus 9 should be equivalent to 11. Sama juga SSTR tambah dengan SSE should be equivalent to SSTO. Okay. Okay, so in order for you to complete the ANOVA table, you should know how to compute the value for the sum of square. Okay, so we have sum of square treatment, sum of square error, and sum of square total. Okay, so the computation for the sum of square is divided into 2. Okay, so there are 2 types of data we have here. We have balanced data and also unbalanced data. Okay, this is example for balanced data. Okay, balanced data here. Okay, if you look here, okay, let's say we have 3 types of gas line, brand A, brand B, and brand C. So we want to observe whether there is difference in the distance, okay, achieved by these 3 brands. Okay, so what we record here are the distance in mile. Okay, whereas for the example for unbalanced data, so we have 3 types of diet 1, diet 2, and diet 3. But if you look here, diet 1, the measurement kat sini kita ada, and dia hanya 4 sahaja, betul tak? So N1 kita ada 4, but N2 type for the diet 2 we have 1, 2, 3, 4, 5, and 6. Okay, and dia ada 6, but for N3 we have 4. So that's why we call it as unbalanced, because N dia tak sama. Untuk type diet 1 we have 4, diet 2 we have 6, diet 3 we have 4. Compared to balanced data, the N, all N are equal. Okay, and N for brand A we have 4, and for brand B we have 4, and for brand C, we have 4. So the total is 12. This one total capital N dia adalah 14. This one capital N dia 12. Okay. So for this example, if you look here, so this is our treatment. This one is treatment. So our K equivalent to 3. Okay. So this one is the distance is our response variable. What has been recorded, we call it as response variable. So our response variable here is distance. Okay, so go back to how to calculate the SSTO, SSTR, and SSE. Okay, so for balanced data, if we are referring to this example, so the formula is given by summation of I up to K and j from 1 to n, okay, yij squared minus y squared over capital N. Okay, same goes to balanced data. The formula is still the same, but the difference here only when calculating the SSTR, okay, for balanced and unbalanced data. Okay, don't worry, later on I will show you the example on calculating all this value. Okay, lastly, to find the SSE, okay, SSE is given by SSTO minus SSTR. So you need to find SSTO and SSTR first, then you can calculate the value for SSE. Okay, now let's take a look into the step in hypothesis testing for analysis of variance. Okay. So again, the step is still the same. It was involved the 5 step. Okay, the first step is state the hypothesis. Okay, so our null hypothesis and alternative hypothesis is, okay, for H naught, you should write as mu1 equals to mu2 equals to ups mu k. Okay, so how to decide on this? Refer to how many k that you have or how many treatment that you have. For example, if you have treatment equals to 4, so meaning that you should write as the H naught is mu1 equals to mu3 equals to mu3 equals to mu4. Okay, and then the H1 is at least 2 means are different. Dia memang fix. Dia tak ada one tail, two tail or left or right tail. Okay, so untuk ANOVA ni H1 dia satu ni sahaja, at least 2 means are different. Okay, for example, katakan treatment awak, okay, you have 6 katakan, so you should write your H naught as mu1 equals to mu2 equals to mu3 equals to mu4 equals to mu5 equals to mu6. And then dia punya H1 still the same, at least 2 means are difference. Okay, step number 2 is test statistic. So the test statistic that we gonna use here is F. So the formula for F is MSTR divided by MSE, or you can just take the value from the ANOVA table that you have developed, or by using the p-value if the question given you the value, the p-value. Okay, step number 3, state the critical value. So the critical value here, okay, we take from the this formula. Okay, the formula is F alpha, degree of freedom k minus 1 and n minus k. Okay, so alpha you don't have to divide by 2. Okay, and then the degree of freedom ataupun V1 and V2 here adalah, V1 kita adalah k minus 1, V2 kita adalah n minus k. Ni kita both, you can got this value from ANOVA table. Okay, kalau perasan dia adalah value untuk degree of freedom treatment, and the other one is degree of freedom error. Okay, then if you are using comparing the p-value, you just compare with the value of alpha. Okay, step number 4, what are the decision rule? The decision rule is we reject H naught if test statistic is greater than the critical value. Okay, this one, test statistic greater than critical value, which is the value of F calculated is greater than F tabulated. Or you can use the p-value approach. We will reject the null hypothesis if the p-value less than alpha. Okay, lastly, step number 5, decision and the conclusion. Okay, so if we reject H naught, means that there is significant difference in the population mean. Okay, if we fail to reject the null hypothesis, means that the population mean are equal. Okay, so you should remember these 5 steps in order for you to conducting the analysis of variance. Okay, now let's take a look into example 32. A researcher wishes to determine whether there is a difference in the mean number of crime committed among 3 districts in state X. Okay, he recorded the number of crime reported in each district for a sample of 5 days. Okay. So, can you identify what are the treatment here? Okay, so we can see that the treatment here is the 3 different district. District A, District B, and District C. So, our treatment or our K is equivalent to 3. District A, District B, and also District C. Okay, and then what has been recorded here? Okay, he record the number of crime reported in each district. So meaning that the number of crime here, the number of crime here is referring to the our response variable. So what has been recorded, we call it as response variable. So our response variable adalah number of crime reported. So this one is example for balanced data, yeah? Since you can look here for district A, we have sample on 5 days, district B also 5 days, district C also 5 days. So that's why NA kita equals to 5, NB also equals to 5, and C also equals to 5. So our capital N here is equivalent to 15. Okay, can the researcher conclude that there is a difference in the mean number of crimes among the 3 districts? Use alpha equals to 0.05. Okay, so the solution here is, first, you have to add up, okay, the value of for district A. Okay, so I have calculated here the total for district A equivalent to 71, district B is 90, district C is 66. Okay, so meaning that we can write here, this one is the value for YI. Okay, YI. So YI yang pertama adalah YI untuk district A lah. So YI dia equivalent to 71. Okay, next. 1011, 1656, 878 ni adalah awak squarekan setiap satu data ni untuk district A. So I get 1011. Okay, and when I'm square each data set in district B, I get 1656. So this one can be written as YI square. Okay, so finally the sum for YI is equivalent to 2 to 7, and the value or the summation for YI square is 3545. Okay, so now you can calculate the value for SSTO. So the SSTO is equivalent to summation of YI square, which is 3545, minus summation of YI 2 to 7, but you have to square the value and divide by capital N. Okay, then we get 109.733. Okay, now we calculate the value for SSTR. Okay, if you look back at the formula again, so the formula is 1 over small n. So small n here referring to 5. So that's why 1 over 5 times summation of YI, but you have to square the value. So we take the value of 71 square plus 90 square plus 66 square. Okay, minus summation of YI, but you have to square the value. Okay, if you can see here, the value is same value yang dekat atas ni. Value dia sama kan? 2 to 7 square over 15, capital N. So we get 64.133. Okay, now we can calculate the value for SSE, whereby the formula is SSTO minus SSTR. And finally, we get 45.6. Okay, then what should you write is you should complete the ANOVA table, or you have to develop the ANOVA table. Okay, as I mentioned, the ANOVA table comprised of column first is source, Column 2 is sum of square. Column 3 is degree of freedom. Column 4 is mean square. And the last column is the value for F. Okay, so you take the value of SSTR that have been calculated and put the value into sum of square treatment. Treatment here referring to the district. Okay, and then sum of square error is 45.6, and then sum of square total 109.733. Okay, now fill in the value for the degree of freedoms. Okay, so the degree of freedom for treatment, we get 2 here because we have 3 treatment. So our K equals to 3. So 3 minus 1, we have 2. Okay, and then the degree of freedom for error here is capital N minus K. So our capital N is 15. Minus 3, we get 12. Okay, and then the last one is degree of freedom for total. Cara dia adalah capital N minus 1. That's why we get 15 minus 1 equivalent to 14. Or you just add up 2 plus 12 and then you will get 14. Okay, now calculate the mean square. Mean square for the treatment. Okay, so how to get 32.067? Okay, you just take the value of 64.133 divide by 2. Okay, if you still remember, column sum of square divide by degree of freedom, you will get the value for mean square. So that's why this value is obtained by 64.133 divided by 2. Okay, whereas this one is 45.6 divided by 12. Okay, lastly, we find the value of F. So F is simply mean of square treatment divided by mean of square error. Okay, these two value kita bahagikan. Okay, 32.067 divided by 3.8, then you will get 8.439. Okay, now we can answer this question. Okay, how to answer this question? It involving this 5 steps. Okay, step number 1, state the H0 and H1. Okay, since we have 3 treatment here, so that's why our null hypothesis is mu A equals to mu B equals to mu C. Okay, and then the H1 is at least 2 means are different. Okay, step number 2, write the test statistic value. So our F here is 8.439. We get from this table, which is ANOVA table that has been constructed before. And then find the critical value. So our alpha is 0.05. So F alpha 0.05, and then you take the value of degree of freedom for treatment is 2 and degree of freedom for error is 12. So look at the table F, 0.05 to 12. Okay, so look at table 9. Okay, so you should refer at V1 is 2, V2 is 12, and alpha 0.05. So the value is this one. Okay, V1 is 2, V2 is 12, at alpha 0.05. So the value is 3.89. So this is our critical value, 3.89. Okay, so that's why I write here the critical value is 3.89. So in step number 4, decision rule, we reject the null hypothesis if test statistic is greater than the critical value. So kalau kita lukis F value here, okay, let's say the the critical value is 3.89. So let's say the rejection region is here, 3.89. And then we get the value for, and then we get the value for and then the value for F calculated is we get 8.3439, so meaning that it was false in the rejection region. This one is 8.439, so we can conclude that the test statistic is greater than the critical value, so we should reject the H naught since 8.439 is greater than 3.89. So we can conclude that there is a difference in the mean number of crime among the three districts. Okay, for example 33, please complete example 33 and also example 34 by your own. Okay, we will explain, or we will discuss example 33 and 34 later on. Okay, so please complete these two examples. Okay, now let's look into inference about pair of treatment mean. Okay, suppose we carry out the ANOVA procedure and make the decision to reject the null hypothesis. Okay, when we reject, we can conclude that the treatment mean are not all the same. Okay, maksudnya there is difference between the treatment mean, but which treatment mean are differ. Okay, for example, let's say we have teaching method A, teaching method B, and teaching method C. Then we have conducting analysis of variance, and we reject the null hypothesis, meaning that at least two mean are different. Okay, so maybe between A and B have different, or between A and C have different, or otherwise between B and C have different. So we can check by calculating or by constructing the confidence interval. Okay, so a confidence interval for the difference between two population mean is given by x bar 1 minus x bar 2 plus minus t alpha over 2 n minus k times square root of MSE times 1 over n1 plus 1 over n2. Okay, so let's say katakan soalan minta awak cari confidence interval for group B and C. So if you have the ANOVA table, then we can use the value of MSE here to calculate or to construct the confidence interval for the difference between treatment B and C. Okay, so this is the alternative for the confidence interval that we have learned at estimation topic. Okay, so remember, under analysis of variant topic, if we want to calculate the confidence interval value, so we should, or we can utilize this formula. Okay, we use this formula. X bar 1 minus x bar 2 plus minus t alpha over 2 n minus k, and then we will use the value of MSE, which is we can take from the ANOVA table. Okay, then how to interpret? So the interpretation is still the same, like like what you have learned in estimation topic. If the confidence interval includes 0, so there is no difference between the treatment mean. Okay, meaning that if you get the value of interval is positive and negative value. Okay, but if the interval does not include 0, okay, meaning that the interval have the same sign, whether negative or sorry, this one is positive. So this indicates that the treatment mean are differ. Okay, so betul kan? This one adalah positive. Okay. So interpret dia sama, tengok interval. Jika passing through the 0 value, meaning that there is no difference. But if your interval value does not contain 0 value, meaning that there is difference between the two groups. Okay, how? If the question asking you the confidence interval for one mean, okay, for one mean also we can calculate but by using this formula. Okay, the formula is given by X bar I, okay, which is ikutlah kalau awak nak cari untuk yang treatment yang pertama ke, treatment yang kedua atau treatment yang ketiga. So the formula is given by X bar I plus minus T alpha over 2 N minus K times MSE times 1 over NI. Okay, so please remember these two formula. Finding the confidence interval. Okay, this is the alternative for selain daripada confidence interval formula that you have learned in estimation topic. Okay, please complete this example by your own.